So let's take a look at the integral rules for all functions. Now in this video I'll be giving the formula for the integral of all functions that we need to know for calculus, and keep in mind that all of these integrals will be indefinite, so they will have a plus c at the end. Now starting off with the first 5 formulas, keep in mind that many of these you may already know by now. So the first one, the integral of a constant times a function f of x. Remember, the constant we can take outside of the integral, so we can rewrite it as a constant times the integral of f of x dx. Now for the second one, number 2, the integral of one function f of x plus, or I should also include a minus, plus or minus another function g of x dx. We can separate it into 2 different integrals and say the integral of f of x dx plus or minus the integral of the other function g of x dx. Now for number 3, the integral of a constant times dx. Remember, if we're just taking the integral of a constant, we take the constant and multiply it by the variable that we're integrating with respect to. In this case, we're integrating with respect to x, so then we take the constant times x, and because this is an indefinite integral, we add the plus c. Now for the fourth one, this is basically the power rule for integrals, where we take the integral of x raised to some power n. Once again, we add the 1 to the power and divide by the same power, and then we have to add the plus c, because this is an indefinite integral, and keep in mind that n cannot be equal to negative 1. Because if n is equal to negative 1, that leads us to number 5, where we have x to the negative first power, or 1 over x, and the integral of that is natural log the absolute value of x plus c. Now going from 6 to 10, the integral of e to the x dx is going to be e to the x plus c. For number 7, the integral of some constant a raised to the power x dx is going to be a to the x over the natural log of a plus c. For number 8, the integral of sine of x dx. Remember, we derived negative cosine to get to sine, so the integral of sine is going to be negative cosine of x plus c. Now for number 9, the integral of cosine x is going to be equal to sine of x plus c. And then for number 10, the integral of tangent x dx is going to be negative natural log absolute value of cosine of x plus c. Now for number 11, the integral of cotangent x is going to be natural log absolute value of sine of x plus c. For number 12, the integral of secant x dx is going to be equal to natural log absolute value of secant x plus tangent x plus c. For number 13, the integral of cosecant x is going to be negative natural log absolute value of cosecant x plus cotangent x, and then plus c. Now for number 14, the integral of secant squared x dx is going to be equal to tangent of x plus c, because remember the derivative of tangent x is secant squared. Now for number 15, the integral of cosecant squared of x dx. Remember, the derivative of cotangent x is negative cosecant squared, so the integral of positive cosecant squared is going to be equal to negative cotangent of x plus c. Now for number 16, the integral of secant x tangent x dx is going to be equal to secant of x plus c. And then for 17, the integral of cosecant cotangent x dx. Now remember, the derivative of cosecant x is negative cosecant negative cotangent, so the integral of positive cosecant cotangent is going to be equal to negative cosecant x plus c. Now finishing off with the last 3 integrals, for number 18, the integral of 1 over the square root of a squared minus x squared dx is going to be equal to arc sine or inverse sine of x over a plus c. Keep in mind, a is just going to be a constant and x is the variable. Now for number 19, the integral of 1 over a squared plus x squared dx is going to be equal to 1 over a arctangent or inverse tangent of x over a plus c. And then finally for number 20, the integral of 1 over x times the square root of x squared minus a squared dx is going to be equal to 1 over a arcsecant or inverse secant of the absolute value of x over a, and then plus c.